radiation intensity of practical antenna, and then what is the radiation intensity of isotropic antenna. Okay, whenever I have DG, then in the numerator, definitely whether I put the notation or not, it's implied always that indicates the practical antenna. Okay, sometimes we will use U alone, because once if it is in the numerator, in case of this formula, that is always indicates the practical antenna. So again, I do not know what is the nature of the practical antenna, because practical antenna can radiate in any direction, or in general, in some book they used to put U theta comma pi, because the radiation intensity of practical antenna is function of always angle U theta comma pi. Okay, because when you put U, don't think that this is constant. This is always function of theta comma pi. It's function of angle. But U isotropic, I know ready-made. That is total power radiated. WR radiated means total power radiated divided by 4 pi. Then I can take this 4 pi out, 4 pi up. Then this is U divided by omega radiated. That's why I am having one new formula. This is 4 pi. Okay, 4 pi U divided by omega radiated. Or if I want to know the directivity, 4 pi is constant. Total power radiated is constant. You cannot change that. But you can find out the maximum value of radiation intensity, because at a particular angle, it will have maximum radiation intensity, U max. Okay, U max. Then simply divided by omega radiated. Once if radiation intensity is maximum in a particular direction, in that particular direction, you will have maximum directive gain. That maximum directive gain is called directivity. Now I have a new formula. This you have to remember always. Okay, directivity, another formula. See, these are all, this is a definition. Okay, U by U is a definition, basic definition. But finally for antenna, you have to remember this equation. Directivity is equal to 4 pi U max divided by omega radiated. Then you know directivity means gain has no unit. Now you know what is the unit of U, what is the unit of omega. Then you make sure that finally it is of no unit. Finally it is of no unit, because always unit has to match, unit both on left hand side and right hand side has to match. Okay, so because directivity D has no unit, please note down, sir. D has no unit, because generally gain will not have any unit. Okay, D has no unit. Then you make sure that what is the unit of this one, what is the unit of this one, what is the unit of this one. Then finally whether it's giving you some unit or not. Okay, you just identify. Okay, now we have derived some formula for directivity or directive gain, but the formula that I have derived is with respect to the power radiated, with respect to the power radiated. Now the new concept comes input power. Okay, new concept comes input power. So now we are going to define what is power gain. Okay, before discussing about the power gain, you should know some basics. Say for example, if I have an antenna, like this, some antenna, now I am giving some power to the antenna that is called as omega W in. How much power I am giving to the antenna, how much power I am giving to this antenna. So there may be some loss due to reflection. You know that once if you have a transmission line, this transmission line is connected with the antenna. If the transmission line is not perfectly matching with the antenna impedance, then definitely there will be reflection. Some power will be reflected. Okay, then remaining power is radiated on the air. Remaining power is radiated on the air. So omega radiated. So the reflection power input power is equal to radiated but the loss is due to not one of the antenna. So the efficiency of the antenna is equal to how much power radiated, how much power is given as input. Okay, how much power is given as input. So in this case, what is the efficiency? I will get 99%. Okay, this is the basic definition of efficiency of the antenna. Okay, eta means what? Efficiency. Okay, see what is the radiated power, what is the input power. Okay, maximum it can be 100%. In all, in actually in practical cases it will be less than 100%. Okay, now you have some relation between omega in and omega radiated, that is decided by eta, efficiency. Okay, so what I can do now, there is a power gain. Okay, there is a power gain. The basic definition for power gain is, okay, already you know directive gain. For a directive gain, you have 4 pi. In the numerator, you are having u. Okay, but in the denominator, you add omega radiated. If you add omega radiated, this is directivity. But now I will put some new notation. Now, instead of omega radiated, I will put omega in, because I can replace this one. Okay, I can replace this one omega radiated with the help of eta into Wn. Okay, omega radiated into eta into Wn, or otherwise I'll do from this only. What I can do, omega radiated, then what is omega radiated? Simply eta into Wn. What is the general formula? Actually, the general formula is, see, directivity general formula D is equal to 4 pi u divided by omega radiated. How can I replace omega radiated? Eta into Wn. So once I can write like this, 4 pi u omega radiated means eta into Wn. The eta goes here. Once if eta goes here, this is eta into D. This is 4 pi u divided by Wn. This eta D, I am calling it as gain. Now I am having some new value, eta into D. This eta D, I am calling it as a gain, power gain. Okay, GP. This eta I am calling it as a power gain. Okay, so in future, what is power gain? Power gain means always eta into D. Okay, power gain means generally G. Okay, G is equal to what? Eta into D. Okay, so
sir?
Yes, sir.
Directivity U max varadu.
U max எங்க சொல்றீங்க? நியூமரேட்டர்லயா? டைரக்டிவிட்டிக்கு U max. Yes, sir, U max. நியூமரேட்டர்ல U max சொல்றீங்களா? Yes, U max you can. Yes, U max only. இங்க தானே சொல்றீங்க? U max. Yes, U max.
Yes.
Yes, U max only, sir. Okay, so now finally my aim is to relate the gain and directivity. So gain is equal to efficiency in the directivity. But one thing is very clear, the gain is always less than D, because eta value is always less than or equal to 1. Then what is the indication? My gain is always less than or equal to directivity. My gain is always, because it's true, because the gain is defined with respect to input power, but the directivity is defined with respect to radiated power, but you have loss in between. Okay, this gain means you are accounting for that loss also. That's why your gain is little bit reduced. Okay, you are accounting for the loss also. Okay, so gain is equal to efficiency into directivity. Gain is equal to efficiency into directivity. Okay, that's the relation between gain and directivity of the antenna. Okay, if efficiency is equal to 1, then gain and directivity both are same. Okay, next, what is effective aperture area? What is effective aperture area?